Standard array, the simplest of all containers. For everyone familiar with C style array, standard array offers the same functionality but better. We will cover all of the basic functionalities of standard array, and if you're interested in a specific part, just skip to the chapter. Hi everyone, I decided to explain the STL. Over this course we will start from the ground up and cover the complete standard template library. So if you're interested in this, stay tuned and please hit subscribe. Today we will cover arrays, so let's start. Let's create an array. We need to include the header of array first. So let's type include array, because this is where the array itself is defined. And afterwards we can declare our first array. We use standard array for that, and it is a template. So inside these two brackets we need to now define the type of our array and how many elements we want to store. For instance, we can type int, which means that each element that we want to store is an integer. And if we type 4, this means that we want to store 4 different elements. And then we can give this one a name. We can call it my array. And then it's good practice to already initialize this. So if we already know what the values are that we want to store, it's good to directly do so. So for instance, we want to store a 2, a 4, and maybe a 5, and then we end by a semicolon. That way we have already declared our first array. Array itself offers 2 different ways to access its elements. If we use array, we can use the add function to retrieve the element at the specific index. So we have here 4 different indices, and we can access each of these indices by, for instance, using the index 1. And just to show you, we will output this one to the console and then recompile and see what the output actually is. So we use here the Clang compiler to compile our program, which is called array.cpp. And after that, we can easily run the program, and we see that the output of my array.add at position 1 is 2. If we change this now, for instance, to position 3, recompile, and then we run the program again, we see that it's 5. So this index here is 0 bound. So if you type 0, you get the first element. If you type 3, you get the 4th element. The second way to access elements of an array is the brackets operator. It's for my array, and we use these brackets to also specify which index we want to retrieve. We can say here also we want to have index 3, and again we output this to just verify what we get as output, short recompile, and then we run the program and we see that we retrieve the same value by using the operator of the brackets. While this is all of the functionalities that array itself provides, there is still a third way to access elements, and this is by using tuple. So if we include the tuple header, by including tuple, we have another possibility, and this is standard get. And standard get, we can then pass which element we want to get in the template operator of my array. And just for consistency, we use also the third one here and output this one to console as well, and it will give us the same value. Let me show you. We recompile the program, and after that we let it run, and we also see it's 5. So it's not technically array that we're using to access it, but standard get, which can access any sort of container. The next way to access elements of the array is by accessing the boundaries. So not random access anymore, but the first and the last value. We can do that by using my array.back. This one will give the last value of the array, and my array.front will give the first value of the array. So if we also output this to console, then recompile it and let it run. And then we will see that it will output probably 5 and 2. So the last element and the first element. These ones are important for operators or for algorithms which consider the first and the last element to be something special. Now the next one is what sets apart the standard array from the C style array, and this is the size functionality. So the array itself knows of its size, which is really useful if you want to pass arrays between functions. So if we use my array.size, this will return the size that we have created the array with. So in our case, it will be 4, and we can also output this one to console. The second way to also retrieve the size of an array is by using max size. So the max size of an array is always the same as the size of an array. So it will also return 4 because this is also the maximum size of an array. The array itself is fixed in its size, so the size doesn't change during runtime, which means that size and max size for an array are also always the same. The two different interfaces, size and max size, only are there to be compatible with all of the other containers which might change size during runtime of the program. So let's compile this and see what we get. And here we see that size is 4 and also max size is 4 as well. The next one is to swap the content of two arrays. So we create a second array, which is also done by a standard array, and it needs to be the same type and the same size. So we also use integer and 4 and name this my second array and initialize it with, let's use 4 ones on this one. And now we can output my array and my second array by using here my array and also my second array. And now we can use the swap functionality to swap the content of the two different arrays. We can do this by accessing the swap member function of my array and passing here my second array, so the compiler knows which arrays we want to swap. And after swapping, we output the values as well, or again, to just verify what actually happened in the program. So we recompile and then we run the program, and we see that at the beginning my array is 2, 2, 4, 5, and after swapping my array is 1, 1, 1, 1, and my second array has now the values of my array. You can also check whether an array is empty. This is also more or less to keep the compatibility with other containers, because the only way an array can be empty if it is declared here with a 0. So we can declare an array which is empty by using standard array integer 0 and name it my empty array, and then we can output the empty function of this array by using my empty array.empty, and this will now return true because this array has been declared empty. Because the size doesn't really change for an array during runtime, an empty array is always empty. Previously we have declared my second array and initialized it with 4 ones. So for 4 values, this is still very well possible, but if you have now a large array which consists of thousands of values, you cannot type all of them. So the standard library offers a possibility to fill any array with a specific type or a specific variable at the beginning. So you can just use something like my second array dot fill and pass the value that you want all of the content of the array to be filled. So we can here pass 2, and then after that my second array should consist of just 2s. So let's recompile the program and then check the output to verify that this actually works. And here we see that after using the fill functionality, all of the values of my array are 2. That's all the basic functionalities that arrays have. And the biggest benefit considered to the C style arrays is definitely that the standard array knows its own size. So you don't need to pass the size anymore in functions. You can just call myArray.size and retrieve the size from that, which prevents memory leaks, which prevents out of range access of the array, and it's just a much cleaner way to code. Also, standard arrays, they cannot decay into pointers, because in C you might know that pointers and arrays, they are more or less the same thing, whereas in the C++ world with standard array, it's always a standard array, so there's no way to automatically decay this one into a pointer. So yeah, thanks for joining me today. I hope you have learned something. Go on GitHub and check out the code on GitHub. And if you don't know what to watch next, I have a good suggestion for you here. Thanks for watching.